Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. Before we get started today, just really briefly wanted to mention that Abner, who many of you may know, he was kind of the original organizer of Handmade Network, which is the place where a lot of projects like 4Coder, the editor we use on stream, Remedy, the debugger we use on stream, a lot of those projects have a home at a place called handmade.network. And he was the original organizer of that project. He worked with a couple people involved, Drone and Andrew, and there's a bunch of people who made it happen. But he's Abner's kind of an organization kind of guy, and so he has decided to run a conference, and it's going to be in Seattle, and it's specifically for the sorts of folks who like low-level programming, like who watch this stream, and he has announced the date. It's November 16th, and again, that's in Seattle. So if you if you think you might be interested in this, there's obviously he hasn't really posted much information about it, so you'll probably be seeing some posts later on about what it's going to be like, and who's going to be talking if there's talks or whatever. I don't know exactly how he's organizing it, but whatever he ends up putting together for the program, that hasn't been announced yet. But if this is your kind of thing, you might want to go ahead and make a mental note to keep or go into your calendar and mark November 16th as something to leave open. And you can also go to this website that he has set up, handmadeseattle.com, and you can put your email address in here to and click on that notify button to be a part of the mailings, which will say, for example, when there is more program information and talking about sort of what the conference will entail. You can get mailed, and also when tickets go on sale, like you can't buy tickets to it yet or anything like that either. So all of that information is forthcoming, and if you're kind of interested in the conference, I would highly recommend going handmadeseattle.com. Make note of that date, put your email address in here, and then Abner will send those notifications out, and you can take a look at the conference in more detail once he's posted the nitty gritty. But yeah, just wanted to make everyone aware of that. It's a conference specifically for the type of people who like to do low-level programming, like to care about performance, like to care about the quality of the code that they write. And if you're watching this show, that's probably you. So if you're interested in a get-together of that nature, this is something to check out. I will probably mention it again on the stream once there's more information, but obviously not everyone catches every stream, so I thought I would just bring it to your attention now. For those folks watching, and again, just so you can keep your calendar free, if that's something you might like, don't plan any mid-November vacations just yet. Stay tuned to Abner's stuff for a little bit more information coming down the pipe. Also, again, that's Handmade Seattle. The old Handmade Con domain name I also remapped here so that we will be keeping an unofficial conference list, so you can see it showed up there. And so we will try to, generally speaking, keep people appraised of if there are conferences for low-level programming that people let us know about. We will try to keep them listed here. Obviously, we don't expect there to be too many. Low-level programming is not exactly the kind of thing that most people care about these days. But for those who do, we remap that as well. So if you do go to handmadecon.com or handmade-seattle. Was it .com or .org? I don't remember what it is. Seattle.com? Yeah. Or handmadeseattle.com. You can get that information. And I think there's also a little news feed here, which has like a little bit more information, like where the venue is, sort of what the layout looks like. You can see it here. So I guess the plan is going to be to have sort of booths for people doing low-level software stuff, just to give demos and show what they've been working on, that kind of thing. And then I guess there's a set up for doing presentations and that sort of stuff. So again, details will be forthcoming once there's a more concrete program for the conference. But for now, just keep the slot free if it's something you're interested in, and maybe just poke your email address into that mailing list so that you can get the information as soon as it's available and get notified for tickets. It's not a huge venue. It's similar in size to the first Handmade Con, I think. So depending on what the demand is for tickets, it could sell out. I think if it sold as many tickets as Handmade Con 2 sold, it would probably be at capacity or over capacity. So you probably do want, if it's something that interests you, you want to get on that early. It could possibly sell out. I don't know, because I don't remember exactly what the capacity was when Abner was talking about it, but it sounded like it was only about as much as the first Handmade Con, and Handmade Con 2, I think, sold more than the capacity of that. So just keeping that in mind. All right, all that being said, let's go ahead and get started today. We basically put the structural sort of scaffolding in place for doing sound. We had already implemented that on Handmade Hero, and so we have all the code that we need, but we've added the notion of tags files as a way of listing all the stuff that we want packed into the game for shipping, and as a way of marking it up with the information that we want it to have. And so since we've done that, I just want to merge that wave processing code into the standard path so that people can hot load wave file entries and have them listed in the same sort of manifest that everything else gets listed in for art. It just makes it nice and simple and clean, so you don't have to think about how to produce multiple assets different ways, or that there's a big difference between art assets and sound assets. I'd rather just have it be nice and uniform and easy to understand, especially since this is an educational project and people probably do want to put their own art assets in eventually and stuff like that to add things to the game, or anything like that. So I feel like it's worth spending some time in there just making sure that all that stuff works relatively well. Now, if I go ahead and open up the import layer, and I open up the wave layer, which has the parse WAV function in it, what I would like to do here, okay, can we note, Miblo, can we note this part of the stream? Miblo, are you out there? Can we note just what just happened? There was a green flash on the forecoder. The green flash is something that we put in specifically to show a render buffer overflow. So I want to be able to send this to Alan. So whatever that timestamp was for the green flash, I need to send it to Alan, because that indicates that the thing I was talking about on the forecoder jam about render buffer overflow did happen, actually. So that's good. So hopefully we can get that marked. I don't know what the stream time is right now. Thanks, Miblo. Thank you very much. Okay, sorry about that. That was just a little forecoder interruption there. Anyway, so what I want to do now is basically take the if zero block out of here. So I want to go ahead and get rid of this, sort of bracer that's around here that was preventing this code from being compiled. What I want to do is transition this code over from what it was doing before to basically doing things the way we need it to do now. But we basically want to do exactly the same thing as it was doing, which is to say we want it to read a wave file or WAV file, parse the information in it, and give us back basically the blocks of sound samples that it uses. And while it's doing that, we don't really ever want to do an assertion. This is file IO, so if it fails, what I'd rather do, because since this is in the actual game proper, now that we have a coherent way of streaming errors out, I would like to issue errors on the stream and allow those errors to be displayed to the person who did the import so that they know that something went. horribly, horribly wrong, right? So for example, you know, the previous way this code was working in a command line utility, because we didn't really care, if you didn't input a sound at 48K, 16 bits per sample, PCM, it would just assert, right? But we don't really want to do that because an assert effectively crashes our app, you know, for all intents and purposes. It grinds everything to a halt. If somebody was running the game, what we would much rather have it do is just say, hey, you know, some of those sound samples that you just tried to import, these ones here are the wrong format. You know, you need to go reformat them, right? So we'd rather be a little bit more user-friendly there, since we now have the opportunity to display error messages. We already did that for the other parts of the system. And so all of this stuff, invalid channel count, like the samples per second, format tag, the whether or not the headers are right, you know, all that stuff should now be handled as errors that we expect to encounter sometimes when someone gives us a bad file, and we'd like to just print out what the problem was. We don't have to be hyper-aggressive. If someone feeds us truly corrupted garbage and we crash, I don't mind. This isn't supposed to be like a secure system or anything like that. But we might as well take the basic errors we expect to see, turn them into printout that an artist or a sound designer would understand, and go from there, right? That's our primary goal for getting rid of those as well. All right, so if we take a look at what happens when we come into parse WAV, we've got a stream set up here where we can start reading from it. The first thing that we wanted to do will work just fine, which is we want to consume one of these wave header structures. And then, like I said, really what we want to do now is just get rid of these assertions and turn them into something that actually just looks to see what it was that we got back and issues an error in the case where we don't get what we expect. So assuming that the header looks like it has the things in it that we want, we're going to call that good. And if it doesn't, we're going to issue an error. Now, this is similar to what we did in the PNG. So you can see in the PNG, right, that it's got like errors that come out here. And that error, when we do like a particular call, we pass an error stream to it. So you can see what's going on in here when this call gets made and you get the stream file there. What's going to happen is whenever we want to print out info, like if we're just trying to dump information, which is in case we're using this as part of a command line utility or something like that, it goes to the info. But when we have an error, when we have something that actually failed, right, then what we want to do is use the .errors stream, right? And that .error stream, I don't actually know what comp data is. Is that just a renaming of, I assume that's what file is, but renamed. Yeah, you can see here that it basically says, hey, I'm going to take that file error stream and make a I'm going to make it onto a memory stream. I'm going to use that file error stream as the error output for it, right? So anytime we're doing something with this file bit here, which is the same as getting passed into our WAV parser, we should be able to say if we want to output an error, no worries. All we have to do is just say like the error stream that we were given as part of this stream. So when we're parsing this stream, if we see an error in the stream, we send it to this other stream, right? It's sort of saying like, when you're parsing this stream, errors for it can go here. Just a convenience of bundling those two things together. We can say like error, unable to parse wave header, right? And again, we don't really know what that means, right? We have no idea what's actually going on there, and it's okay. Like, we only need to understand the kinds of wave files we expect to see. So if there's some other kind that someone's trying to import, it's not our problem, right? We're not a sound editing package. We don't have to try and support all kinds of crazy formats. We can just look at the basic ones that we want. Now, the same thing is going to happen here. So what we want to do instead of these assertions is we want to have a notion here of like format okay, right? And we want to basically have something in here that's doing the check and says whether the format's okay or not, right? So when we encounter a wave chunk format field, what we want to do is do like an if here. Oops. That was a bad cut and paste. There we go. So what we want to do is turn this check into something that says, look, if all of these things turn out to be true, right? Like that. So if the format's PCM, if the samples per second is 48K, and the bits per sample is 16, then this is the format for sound that we expect. We also check the block alignment because we don't actually support multiple block lines. We could support more of those, but, you know, 6 of one, half dozen the other. So anyway, if we need to, we will. But, so assuming that the format is what we expect, we're good to go. So we can say, like, format OK equals true. We can say that the channel count equals however many channels it said that there were. And so once we know that format, we're good to go. If it's not the case, we can error out like we were before, but we can also print out, for example, into the error stream what the offending settings are, just so people know. Might make it a little bit easier to see what's gone wrong. So we can say into the file error stream, we can just be like, oops, error stream, unsupported WAV format, you know, %u, comma, %u, comma, %u, comma, %u, kind of a thing. And maybe I'll label these, so like, maybe something like this. That's the format. Here's the hertz. Here's the bits per sample. And here's the alignment. And then I can just print these values out. And that way, if we do encounter WAVs that are set to something wrong, this would tell you what the setting actually was, right? So that you would know that you could at least eyeball it and say, oh, it's supposed to be 4800 and, you know, the thing reported 44. You know, that kind of thing. So let's just go ahead and dump those values out here. So here they are. And samples per sec, bits per sample, and block align. And then we will, you know, have an easier way to see that. If we see wave chunk ID data, that's basically telling us what we actually want to know there. The problem here is we're now at the point where the Riff iteration part of things comes in. And we want some way of using, we probably want the equivalent of the Riff iterator to access the data in here. And so I don't actually know, again, exactly how we want to do that. We have to go look and see how we would like the interface to go and whether it should sort of be a part of the Stream API or not. I think ideally I would like it to be, but, you know, we need to play around with that. So I'm going to leave that and just assume that we will mimic this API one way or the other, and I'm going to proceed down to the next part of the code. So in here we've got an assertion where we've got channel count and sample data. And so what that is doing is saying, let's make sure that we got both this and this, right? Now, maybe one thing we could do is just say, you know, maybe we can use that as good enough. I was going to have that format okay in there, but maybe we can just use this. And so what we can do here is say, look, if both of these are okay, then we can go ahead and do the parsing. If they're not okay, then we're back to another one of these sort of error conditions. So I can say, you know, error couldn't, I guess, like, just unrecognized wave data layout. Because basically, if we, you know, if we get here, then the problem is we can't actually know once we get to this point. We don't know like what kinds of other wave chunks might be in wave files, right? There's probably extended versions of these things that don't use either maybe the format or the data or both, and they've got other chunks that specify information that we just won't understand. And so when somebody gives us one of those that doesn't have, you know, everything that's the right exactly the way we want, we're not going to try and figure out what's going on. We're just going to error out and say, look, we don't understand this WAV file. Save it in a simpler format. Use a different tool to convert it or who knows what. But we need something more basic, right? But assuming that we do get both the sample data and the channel count, then we can sort of go from there. If you look at what's going on here, you can see we're sort of starting to set like result information. That result is one of these Sound 16 things. We can still basically do exactly what we're doing here. To set the channel count, we just set it to exactly what it says. To figure out the sample count, we have to do a divide because it looks like we don't ever... The WAV data block just gives us a size. It doesn't tell us how many samples there are. So it assumes that we're going to do a divide to figure out how big the data that's in there is. So that's what we have to do. So when we do this, you can see here, we've got a channel count, like 1, 2 thing. I don't love that. I feel like we should just go ahead and support arbitrary numbers of samples, of channels, because it's not particularly hard for us to do that. And so if you look at what's going on here, you can see, for whatever reason, we kind of do arbitrary garbage here where we are like padding out the end of the thing to blocks of 8, looks like. I think that's just in case we want to load them SIMD wise, you know what I mean? None of that is relevant to us, I don't think. I don't think we actually care about that. And padding we definitely don't care about either. And the reason that I say I don't think we care about that is because our model for asset loading now is pretty reasonable. And when we load in, we can do the padding on load, right? Because we're going to load into a block of memory that's designed to be handed to our mixer. And so we don't actually have to do padding into the actual destination. That seems like it's totally unnecessary. So any kind of like padding like that just seems dumb. And I think we'll just skip that, right? Unless I can find some reason when I actually go to do the block-based loading of these that makes it so that I can't do what I just said. I'm not super inclined to pad the storage because there's no reason to pad the storage of the things. We might as well just pad the in-memory version, right? Okay, so if we want to expand this part of the code to be better about actually unpacking any arbitrary number of channels, then what we want to do, obviously, when we get the sample count and we do this operation here, what we want to do is save that sample count, right? So at least we have that now. So this basically gives us a way of setting all of the result stuff, and the only thing we haven't done yet is the samples part of things, right? Now, I think probably the easiest way to do this, like I was saying, is we want the code that's calling us to be able to think about these things in terms of just straight up samples that are de-interleaved. By default, I believe the way the WAV format will work, and you can see us doing the demultiplex here, actually, right? By default, what happens, I believe, is they come in like order of channels first, then sample. So it's like if you had a stereo sound, it would be like sample for channel 0, sample for channel 1, sample for channel 0, sample for channel 1, right? So they're interleaved, and all of the samples that you would want for a given specific sample, each channel sample, are all packed together. We're not going to want that, I don't think. Rarely do you want things organized that way. Well, I say that, and as I'm saying that, I'm actually probably wrong. If you think about what probably happens in the mixer is you would apply all of your operations to one sample across all channels. So you're probably going to do something like load an 8-wide float register with all of the samples with all of the channel samples for a particular sample index, apply like the volume multiply against that, and then continue. So in some sense, keeping them interleaved does seem to make a fair bit of sense, because you're going to want them interleaved when you actually process them later. Right? I mean, you see what I'm saying there? The reason I'm hesitant to really do that is because most of the time you don't really do samples that have you don't really do sounds that have 8 channels or something as the sound. A 7.1 sort of thing where you have like 8 actual channels that you're outputting to some kind of a crazy sound setup. I don't think that usually actually has 8 sound samples, because typically you have to spatialize the sound first. So you're usually dealing more with a mono sample, like a mono one channel, and then the spatialization outputs what should be going to each of the like surround sound things, because that's the only way you can have sounds move around, right? So sometimes you have particular sounds that have been mastered to be played, and they're not gonna be moving, or if they are moving, it's baked in how they move. Like, so it's like a fixed thing, and that would want to be interleaved in that way, obviously, because I think that would be the most efficient. But just thinking it through, I'm like, is that really the case that we normally have? Because it's kind of feels like it's not, right? And so I really just don't know what to make of that. I think what we really want to do is just have the samples. We would load them in. We would blow out each, we do a series of unpacks to blow them out to at least 4 wide, possibly 8 wide. Do the mix down on the mono to put it to each of the different channels, and then go from there, right? So again, that just really feels to me like not interleaved. If we were gonna know, if we knew we were always playing back 7.1 direct, and we didn't have to map an n-way map to the different channels, then sure, but I don't think that's realistic. I just don't see us doing that. So I'm thinking again that this just should be de-interleaved, and essentially when you load a sound that's got multiple channels in it, they'll be treated as multiple sounds, more or less, right? On the outside. So, like our sound assets, we may literally never allow a multi-channel sound asset ever. It may be that we just have, if we want multiple channels for one of our sounds, like for example, if the music wants to have a left and a right channel or something like this, then what we would do is have 2 sound assets, one with a left tag and one with a right tag, and you load them both and play them at the same time and assign their channel, accordingly. I think that's more what I want. And again, it's just sort of guessing based on how I see these things tend to go. Your mileage may vary. Think it through and think about what you're actually doing, and the answer should become clearer as you go further down. But that just feels like the right thing to me, because I think most of our sounds are going to be mono, and then they'll get sort of spatialized. And that just suggests that de-interleave, a path that expects per channel work, just makes a little bit more sense to me in terms of how things will fall out later down the line. So once we get the channel and sample count in here, doing that de-interleave shouldn't be too big of a deal. We know exactly how big of a sound we're going to need. We can use this right here to do our push, right? And so in a sense, actually, I guess this will get done for us. So really, I can just do this. I can say, look, here's the channel count, here's the sample count. Go ahead and do that push for me. This will give me exactly what I want, I think. So I can just say that arena that you gave me to store the thing in, go ahead and make a block of memory in there with this sample count, this channel count. You can see that doing the layout there. We can make this a little bit more understandable by doing this. It's the same exact equation, but just that way people can see that this is, it's 2, what's 2? Maybe they'd think that was like for stereo or something, right? If they didn't think about what was going on with the channels. If I put that size of in16 there, at least, people maybe think, oh, right, that's the sample format. So that's where they're getting that from. It just makes that line a little bit easier to read, maybe for people coming at the code first time. I should use our format. So there's a S16. So coming back here, we've got the WAV chunk IDs stuff. We're reading that stuff out. Coming through here, got both of those. If we assume we got both of those, then we can come through and actually do our reservation. We now got the memory. So then all that remains is we now have to kind of do that deinterleave. We don't know how many channels we have coming into this, so we have to make our loops actually use a variable number of channels, because channel count could be set to literally anything. So what we want to do is do a sample index here where we loop through all the samples that we got, like so, and then we're going to come through and loop over the channels like this, and then that should give us all we need to demultiplex the, to deinterleave those samples as they come. You can see here we were setting up some pointers. I don't really care about that right now. I'm going to get rid of that. And you can see what we were using for that demultiplexing or deinterleaving, depending on how I want to talk about that, right here. So what we were doing is saying, oh, okay, let's grab the samples out exactly like this. You can actually see how we were doing it. I guess... So what we did here is we actually just deinterleaved it in place, right? You can see us doing that here. We would like load the source, save it, and then do it like this. I don't really care about that. We don't need to be conscientious about the memory use here. So I'm not super inclined to swizzle it in place. I don't really see the point. So I don't know, that just seems like it's not particularly necessary. So what I think I'll do instead is just have like a sample pointer, and so we'll just demultiplex it into, from a source into a destination, basically, and we'll go from there. Now what I might do as well is I might make essentially an internal call here on the Sound16 that allows you to get out where each channel starts, right? So I kind of want something that's like get channel samples, right? And this way you can say for a given Sound16 that you wanted to access, and you tell me which channel index you wanted, right? First of all, I'll cert for you that you're not asking for an out of bounds one, because that's just a straight up bug and shouldn't happen. So we'll make sure that you're asking for one that's okay. Assuming that you are, we will then say, okay, whatever the sample pointer was, we're going to give you back the correct block of samples in this overall block. That's the one you wanted. So doing that's easy. We know that there are sample count samples per thing. So we just need to say, look, whatever the channel index is, times whatever the sample count is how far we would go for every different one. Now remember, we don't have to multiply by the size of this S16 because all of these pointers are already S16. So C will silently do a little shift up by 1 in there for us to account for the size of the actual sample. So I believe we should be done with just that. Go this many samples forward based on the channel index you provided. Because it's already an S16 pointer, it will move twice that far in actual memory space. That's what we want. So in here, what we can do now is just say, all right, for every one of these channels, we just say get channel samples for this channel index. And for each of these, we just would pass whatever the result, that result is. This will give us back where we want to write. And so we can just say, all right, wherever that block was, write in whatever the sample is that we're talking about here. So this sample data, right, I can start at the beginning of it. like that. And we know that this points to the beginning of all of the samples. And we know they're interleaved, so I should be able to literally just do, you know, that. So basically, get one sample at a time and spread it out to each channel as we go. So take channel 0 sample, put it in there, take channels 1 sample, put it in there, right? So we're just grabbing the samples one at a time in order and diffusing, you know, we're scattering them out to each channel's now unified block of samples in sort of just a very simple scatter operation, taking an interleaved source and putting it into deinterleaved destination. We don't need this anymore. This was the old one, right? So that should produce for us clean versions where each channel has its own block of contiguous samples ready to be accessed by the external code for whatever it wants to do. Now, coming through here, you can see there was even a to-do here, so maybe this is just, I don't even know if this code, I guess we didn't really even finish it. It only supported one channel, I guess. You can see it cold setting the channel count to 1. And so we're already better than that now. This was, this padding and stuff, you know, all this stuff should just go away. We don't really want any of that. And in here, where we do this else was just a vestigial remain from the old one. It's actually that now, right? And this is the finished routine. So really, it's pretty great, right? Loading a sound out of a WAV file is like, you know, here's the PNG, right? Here's all of the PNG code we had to write to load the images because of the, you know, compression, I guess, that's in there, which is kind of janky. It's not a great compression format. And for the WAV, since we don't have any compression, it's really pretty straightforward if you have a way to iterate Riff data. So that just leaves us with one more task, which is we have to have some way of doing that Riff parsing. So let's go ahead and jump to the Riff iterator that we had already written and just take a look at it here. You can see it. I'm going to grab this code and then we're going to decide what we want to do with it. So this is the code that we wrote for the original asset importer. Obviously, we want more or less the same thing, but we need to think for a second about how we want it to look. So let's take a look at that and figure out what we want to do. So if we're talking about a stream specifically, and so if I go over to the stream set of things here, you can see that the stream sort of expects to be able to operate on top of a variably filled chunk buffer, right? Like it doesn't assume that everything is contiguous. So you have things like grabbing bits out per and so on. So, you know, it looks to me like this is just something where the original way we were doing the Riff iteration probably just is better. And so I'm going to go ahead and say, let's keep the code the way that it was. It just looks structurally better. I don't think we want to support reading WAV files out of this stream format because we don't need to. There's no reason for us to chunk them. We can load the whole thing at once. So I think we want to just say, forget it, like let's just make our own version that does use the Riff format reading, and let's take a look at what that would look like. So if in here I do a handmade Riff, just to put these in, so here's our Riff iterator, and that way this can be used to read any old Riff thing we want. And so we can just say, look, there's the iterator. It's just a pair of pointers. It expects a contiguous thing to parse. And then I'll pull this stuff out here. And we can even do a little sort of header version where we just show how you might do this. I don't remember what all the things are that we actually call here, but I think we actually call all of these. Am I wrong about that? I think all of these are actually called. So if we just kind of convert this to like our modern way that we were doing things, leave it like this, I think we're in good shape. There we go. And just, you know, here's a little Riff reader with a little API for it. It's all nice and bundled up for you, and should be pretty easy to use. Now, okay, that's interesting. So for some reason I guess we were using this stuff here because the wave chunk actually was all we would ever need. But we should probably not do it quite that way. We should probably actually have a thing here where we use a specific chunk header, right? Something like that. It's wave chunk, right? So it's actually this. This is the one we're talking about. Although they are the same, right? Something like this. So here we kind of say, look, there's a Riff chunk header, and so that way we won't require there to have been a wave chunk defined in any of these kind of circumstances, right? So it can just do that. Because these are just hard-coded to read wave. I mean, it would have worked for any other thing as well, but we might as well just clean that up a little bit. Right. So that seems good, and if I go ahead and just clean up the rest of this and make this good to go, I think we can just start using that. Now, there's a couple other things we want to take a look at real quick, but we'll get to those in a second. This all looks fine. Let me see here. I think we might want to make a little way, a cleaner way of saying that you want to read the initial header. That's sort of a separate part, so we can take a look at that in a second here. Let me just get these two calls in there. And there's our Riff reader. That all looks pretty good. And again, that allows you to navigate through the whole Riff file pretty easily. So I think the only weird part is that in the wave reader you can see right here we say, like, we want to get the header, and there's that wave header. So I'm kind of wondering, just trying to think this through how I want this to work. I wonder if this is generic, like, I kind of feel like this might just generally be a Riff header, like other Riff things would have this in it. And if that's the case, it shouldn't be called wave header, it should be called Riff header. Similarly, this wave chunk doesn't really need to be here either. In fact, I guess I don't know, does anyone even use that? Yeah, so really, this doesn't even need to be there. And I'm thinking that maybe this can just be Riff header, right? And then the first call you can have is, you know, get the Riff header out of this thing. Just what I'm thinking. I'm going to take a quick gander at the docs, assuming that there are any, and see if that's true, because I don't actually know. So let's see. I mean, I probably did know at one point, but I've long forgotten. So where is the definition of the header of the thing? Let's see. So are these docked anywhere? Format. Isn't there something that just says what the header would be? All right. Let's see here. Whoa. This is actually the Library of Congress? The Library of Congress actually has an information about the Riff. Oh, okay, that's pretty cool. Anyway, so I just want to see if there's a definition of header that suggests that across multiple Riff files that's the same header file, generally speaking. Because I don't know if that's true or not. So I'm kind of interested to know how that works. I know that the chunks are generic, but I just don't know about the headers being generic or not. That I really just don't know. I would assume that they are, but I just kind of wanted to, I was hoping that I could get some kind of a more specific definition that said that that was true. This is probably what I want, compound file structure. So maybe, I assume, maybe 218, maybe not. Let's take a look. I can't actually tell. Well, no, that's not really what I want. Yeah. I just want something that says what starts at the top of the file. That's like all I really wanted. But it doesn't look like that's forthcoming, unfortunately. Come on, people. I'm just looking in the wrong place. I mean, I know it's not that this isn't defined. It's got to be. Like, it's got to say what the file starts with if it starts. I mean, you would think that they would have something that just says, here's what it is, right? These... Riff WAV, so it's like they do have a definition. So the fact that they sort of have Riff WAV in it suggests that it is a standard chunk type, right? So that Riff parentheses, I think because I see it everywhere, I can just assume that the header is the same on all of these. And it's just the 4cc, and it should be the same. So I'm rather than continue to sort of pore over those docs to try and find the official confirmation, I'm going to say that this is actually also generic, right? So I think I should be able to do something like this, where I just say, all right, these are actual file specific things, this like wave format and these enums, but this is not. And also, you know, this Riff code thing should probably go in here, right? That's how you would create that. And this we also would want for this, we can probably make that exist outside. So we could say that. I don't actually know if we want to do that exactly, but something like that, right? I don't know. So, assuming that we have something like this, we could potentially use this to read any kind of Riff file now. So that's all I really wanted to get to. In terms of how the parsing starts on one of these, so this is the part where we don't really have anything in specific. You can see that it starts the parse chunkat stuff here where it skips over the header. So what I'd rather do than that, I think, is I would rather have a call that, you know, get rid of this and do something more like up here. Let's see, how would I do this? I'd do something like this. That up here. Let's go ahead and loop over an iterator like so. I'm going to get the next chunk down here. So it's a while loop now, and the iterator will just flow through here. So we'll do something like, you know, iterate Riff like this, and rather than ever calling parse chunk at, we will just have this provide us with the buffer. That's the contents. We'll pass that in. And when we do this iteration, we will have a thing that allows us to get back that header. So we'll assume we have a Riff header like this, and we'll say, what are we saying here for it? Get next chunk, get header chunk, something like that. So maybe this. How are we doing? Okay, so we're just doing it this way. Does this make sense? That seems a little bit better to me. And now this would work for any Riff file, even though we're not really doing anything differently. It's just the fact that we kind of unwaved it is kind of nice. So that's consistent with how we'd parse any Riff file, which I just think is a better way to go. In case we ever wanted to use this code for anything else, it's just, you know, there's no reason not to just do a little bit of cleanup there so it's not dependent on WAV for no real reason. So I think we can do it this way, where we just say, like, iterate this Riff, get us the header chunk out of it, which is, you know, we know that's going to be the first thing in the file. Then go ahead and we can process the rest of it, go to the next chunk. You know, here's the, we can even do this if we want, because we don't really need to do it if we're not going to actually, if we don't actually recognize what this is. This right here would be that, and off we would go. So I think that should do it, and then the rest of these calls are exactly the same as they were. That's really it. I don't know about this guy. This seems maybe not as good, because if we do a get chunk data, that's not actually going to guarantee the size is correct. So we may want to actually have a more specific, like, we could actually have this take what it's trying to look for and then validate it. I don't know. Not sure how I feel about it one way or the other. I'm going to go ahead and pass errors as a separate stream now, so we can get rid of this. And then we can go through all of this and have that output to the error stream. And that should be good. I need these two calls to actually exist now. So I need a way to iterate Riff over a buffer. And then I need a way to get a header chunk from one of these iterators, right? So looking at how we did the iterator, I guess the size part on... So I'm guessing maybe this API wouldn't quite work because the next chunk part of things wouldn't actually work. It has to be on a chunk header for that to occur. So I think maybe what we want to do is change this a little bit and say that this should look more like this. Right? So this would move us to the first chunk automatically. And because that's the only thing that we actually can do, there's no way for us to do anything else, really. So in here, it would be more like this. Right? And then this code just looks like that, and off we go. So I think I'll do it that way. That just seems a little bit better. We'll leave it like that for now. And if it turns out that that's really bad and everything is horrible, then we'll figure out a way around it. So assuming that it looks like that, then really what we're going to do here is we're going to call parse chunk at right off the bat, right? So what we want to do is say, okay, assuming that the buffer is large enough, we'll do something useful here. Otherwise, we won't. So we'll sort of have a case where we would just clear whatever is passed into us if the buffer isn't big enough. So if I go ahead and jump to our buffer struct, that's not what I wanted. There it is. So we have count and data here. So I'm just going to say, look, if the count is greater than or equal to the size that I expect for a Riff header, then we're in business. If it's not, there's nothing I can do. So assuming that it's all good, then what I'll do is I'll just say, great, let's read the header out of here, and then let's actually parse the chunk. That's one ahead. So here on Riff header, this is valid is probably important for us to do as well. Well, okay, we'll get to there. So anyway, this Riff header, the buffer data that we're actually looking at here, we can just say, let's interpret that as a header structure, put it in here, give it back to the person who's looking at it later, and we'll assume that they will validate it however they want to validate it. After that's done, assuming that it actually worked, what we'll do there is we'll take an iterator and we'll initialize that to something that has the correct structure for this. So I will return an iterator that comes back from this parse chunkat call, right? So now what we want to do, and I can look at the original one we did here, you can see how we were doing that parse chunkat. We want that to essentially occur like right here, right? So you can see what we were doing. We were saying, all right, so wherever the header actually was, we want to go one past that. And then we also have the header size field -4 for the advancement. That's saying how much header data there is, I guess. Let me look and see. So this size field... Wait, so could we actually have used it as if it were one of these? Maybe we could have. Maybe I was wrong about that, because it does actually have a size field in it. So I wonder if this advancement code is actually the same. It looks like it's not, because it looks like you have to account for the fact that the file type ID was actually known to be there. Because you see that -4, right? Oh wait, no, but that's fine, because that would just be the size of the chunk header. So it feels like you could just call it next chunk. So I think maybe that was premature, because these are actually the same, right? This is actually the same here, right? One of these is in there. So I might just do that. Maybe I spoke too soon. So maybe, and we'll see if this is actually true, but maybe if you call iterate riff, all you really have to then do is tell it to parse the chunk at that location, and it can just advance as it normally would, because I think this is what it would produce anyway. I don't see a lot of reason why that would fail. You're just advancing by the size, which is what you would expect to do anyway. Although the stop pointer... No, the stop pointer would be the same, right? Because it's just the end of the file. I'm torn. I don't really know how I want to approach that. I'm gonna keep it separate. I'm gonna keep it separate. We'll keep it doing the way that we were doing it, and we'll go from there. All right, so what I want to do here is say, okay, the buffer data fields that we're talking about, where the data actually lives here. what we want to do is start after the Riff header, right? And then in here, this is exactly the same thing, so we're actually just passing the exact same thing. But we want to take that header size and say that's how much of the file we're willing to read. And then the -4, I'm assuming, is getting rid of the file type ID, which is part of the contents. Because these block sizes, I guess, are inclusive, right? They include their own data as well as all the subdata. And so this is just saying, here's the range, right? We're going to go from here to there. I might introduce a pointer just for that, just so it's clear that these are exactly the same, like so. And so it's just data start and data start plus header size -4. And I think that would do it. I'm going to see about how that plays out and if there's anything that I don't like there. We need to include that, obviously, inside handmade.cpp when we're actually including like pings and WAVs and all that nonsense. We need to include our reader. And so in the H file and in the CPP file, where we were previously encoding file info stuff, I think we're good. So let's see here. What's going on? Missing type specifier. What? Did I not have? We have Riff iterator as a type, don't we? Yeah, it's right there. What's the problem? Did I not save the file or something? Handmade.h. Oh, no, that'd do it. All right. So let's move along here. What have we got? So the WAV FMT stuff. What's the problem? Why are you complaining? The Riff codes here, how is that not defined? Oh, because it's, yeah, well, it isn't defined. That's actually true. There we go. Yep, I agree with that. Parse chunk at does not take one parameter. Well, we fixed that. Let's see. Previous local iterate riff. Next chunk, that's true. Didn't want that. That was just a bug. And let's see what else we got. Wave format undeclared identifier. Okay, so did I not define that? So it is here. Oh, that's right. I made these lowercase because I didn't like the fact that they were capitalized. That looks like the only place we used it, though, so we should be okay. Static function sound at16 parse WAV. So we changed the format of that. So we got to go ahead and change the forward declaration and the call. So instead of what we were doing before, well, we need to do that. And so we should get an error where that was called. And here it is. So if you take a look at the content stream that's being made here, we actually don't need that now. We're going to pass these two things directly. And that to-do turns out to be true, right? We want to pass just the buffer. So the answer to the to-do is yes, we should. So that finishes up the WAV parsing, and that's great. And so now we can debug that code and make sure we can actually parse WAVs just fine. What won't actually happen is our asset won't be imported. The reason is because process audio import is now what we have to actually implement, right? So assuming that we got our sound samples, we would come in here and we would end up in a situation where we actually didn't, we'd just be like, all right, you told me to import this thing, but I don't know how to do that, right? So that part right here, we just have to figure out a way to update the HHA file with that new information. And that's something, again, that we've already done. So it's not like we really have a whole lot of work to do here. What you can see is inside the asset, we now have like data offset, data size, first tag, one pass, last tag, type, that stuff. If we just set up that information exactly the way we were setting it up for everything else, we end up down here in the HHA sound part of things. That has the sample count and the channel count, and the chain information, which is if we want to break it up into pieces. And what you can see is the data that it wants is exactly the data we provided. So we should be able to write that out pretty much verbatim because this is all exactly what we want. So the only thing we really need to do here is the HHA sound chain part of things. I don't actually quite remember how this was supposed to work, but I think what we want to do is we set HHA sound chain advance, and then I think what it does is it just adds 1 to the asset number. So basically we just put these assets like in a row into the file, and that allows it to do streaming music, you know, for things that we don't want to load the whole thing in at once. If I just quickly do a search, because I just want to see where the HHA sound chain stuff is at. So HHA sound chain advance. Inside the actual handmade, like this part here, right? I just want to verify that's what happens. You can see it happening. It's just taking that asset ID and adding 1. So what we can do inside the import asset, you know, path here is we can look at the sample count and say how often do we want to hit the disk for this thing, right? Alternatively, we can also look at that channel count stuff. But again, what I think I want to do is just break them up into channels. So I think what I want this to look like eventually should be something like this, right? Channel index equals 0. Channel index is less than sound channel counts, plus channel index. Each of these should be its own asset export. It should use a tag in the file format that's about which channel it is. So for example, in here where we've got, you know, all these different tags, to identify what's going on in our data, I think what we want here is channel index, right? So that way sounds can just say, this is the channel index that I'm talking about for this sound, and off we would go. So that, put this in here. That would just allow us to again demux those sort of compound sounds. If someone does feed us some kind of weird like Dolby 7, was it 7.1 is kind of the more standard thing nowadays, right? Yeah. I love Dolby is such a train wreck in progress. All of these sound formats are so ridiculous. But anyway, so I believe 7.1 is kind of what you would do nowadays most of the time. Like, I mean, just look at these things. Look at how many stupid formats. Like, God. Just, I don't even want to get into it. I hate this kind of crap. Like, how hard is it to just come up with a spec for sound? It's like the simplest thing. And they massively overcomplicate it. It's nuts. Anyway, so Dolby 7.1 is probably a pretty safe format to go with. The reason I like 7.1 is because it happens to pad out to an even number for SIMD, right? If you're going to mix down to 7.1, you've got 8 SIMD lanes, which is 2 SSE registers or 1 AVX register, and that's just kind of nice, right? So I would say Dolby 7.1 is where we should live here. So if anyone does feed us some giant 8-channel sound, we'll demux it. Later on in the mixer, when we're mixing everything down, we output to 8 channels. We can restore that sound as it was if we wanted to. And other sounds that are supposed to be spatialized, we can place them as we want them placed at that time. But generally speaking, I want those channels, I think, separated out into separate assets. When we are doing this way, also for each one of these, I want to divide the channel up into blocks based on the sample count so that we can have some notion of what the maximum sample count is. We want to read. I don't know what that's going to be just yet, but let's just say, you know, that we said that we wanted, I don't know, something like that. 64K worth of samples. I don't know, 256K worth of The sample count, it's really, so 128 would be if each one's 16-bit, right? Then each sample count is going to be, that'll be 256K of load per time. You know, we'll make up something there that we like. Who knows what it is. But what we want to do is say, all right, there's some max sample count. If someone feeds us a sound that's longer than that sample count, so it's like music or a very long sound effect, we're going to break it up into blocks that can be streamed incrementally, because obviously we have that support in the mixer already, so we might as well use it. So what we'll do here is say, okay, when you feed us one of these sounds, we'll sort of do a loop here, going through what we've got and using the max sample count to break it up into chunks as necessary. So we'll enter into a loop here and we'll say, all right, the sample count right now, we can actually do this here. We'll say like samples remaining, or maybe sample count remaining. So what we'll do here is we'll say load up the sample count. We'll do a for loop here, and we'll say the sample count for this interior section here is going to be the sample count remaining. If that sample count that we end up with is higher than the maximum, so we would overflow what we're saying we want our maximum block size to be, we'll truncate. Then we'll write it out, and we'll take the sample count remaining and subtract that sample count from it, right? We can also do a sample pointer, right? So we can say the samples are, the samples are here, so get those. And every time we advance by however many we consumed, that leaves us here with a nice way of ready to write out an asset of particular sample count and a particular sample pointer, and we're ready to go, right? So I think that should allow us to do an audio import there as we would. And so just looking at how the asset data stuff would happen, you can see like the sketch of that in the image version of this, right? You can see all of that happening here. And so what I want to do is have that same thing happen in process audio import. So what we would be doing there is saying, all right, get this exact same operation where we reserve the data and everything. We want to do exactly that. And then we want to actually set up the rest of this stuff accordingly. The file asset indices part we'd even use, but it would just be for 0, 0 because we... oh, well... no, yeah, we don't really need any other information there. That's pretty much sufficient, right? All right. So looking at this, we'd have the same thing. Here's the asset index that we'd be trying to figure out where we'd be writing it. If we already have an existing asset index for it, I guess we can just overwrite that asset. And so that's all we're doing here. So we want to do that same process, and again, we just don't need the tile part of that. So I don't know if we want to make this stuff... I don't know how much of this we want to just clone and how much we want to actually have like a code path that we share. So I may try to pull some common code out here once I see what it looks like, but we'll cross that bridge when we come to it. So assuming that we look in the 0, 0 location, because there's no such thing as a gridded sound import for us. Assuming that we get it, we use it. If we don't, then we reserve it, and off we go. Assuming we got one, we now know what the asset size is going to be, right? Because we know that it's just the sample count times the S16, right? That's just how big it is. Not a whole lot we have to do there. We don't need to do anything. Well, yeah, we would need to do an unload here. We don't have an unload for sound, so oops. We may have to make one of those. You can see in here it doing the clear on this asset. We don't need to clear like the equivalent of a texture handle because there isn't such a thing. So I don't really know that we need something quite this hardcore, but, you know, if I do an unload audio, and we pass like a audio ID, what is it, sound ID? Yeah. So if I pass one of these and we do the exact same thing, I don't really think we need to do anything else fancy there. What we can do is just go ahead and set it to unloaded. I don't know that we need to do anything else because there's nobody depending on it. But we should keep that path in place so that in case we do need to do something more fancy in the future, we could. I think that's probably what we want to do. All right, so in here where we have the asset file index, desk file index, strictly out of curiosity, clearing the texture handle, I guess we just let it get reclamated some other time. Yeah, I guess the least recently used, I'll just clean that up. But anyway, so we then need to finish this off. So we're going to say the desk file index and all this stuff is pretty much the same. So that does kind of argue for maybe sharing these code paths. We need to reserve data for it if we don't have enough room, assuming we do. I don't know why this 64K part is relevant. I don't think we care about that. So now what we need to do is we need to set the actual sound data. So in here, where we look at how those HHA sounds are set up, here's where they are. We got the sample count and the channel count. So we know what those are. There's the sample count. And instead of source image, it's just, you know, that's just the sound. So there we go. At the moment, for some reason, those are actually big. So we don't actually have to truncate them. We could have truncated the channel count. Probably we didn't decide to because we had nothing else to store in that room that we would have used there. Looking at this, probably what we should have done is make a U16 channel count and a U16 chain ID. There's really no need for those to both be 32. That's just way too large. There's no point to that. But yeah. Just make a note of that. So that's just kind of dumb, but, you know, no one's going to care. That's, you know, you have these sounds that take up many, many kilobytes, and then we just have, like, 16 wasted bits in here. No one's going to care, right? It's not going to affect anything we can do with these, so it's not important to get it right, but, you know, it's just worth noting. It's dumb, regardless. So anyway, getting rid of all of this stuff, I don't think we need any of this. That can go. So what we really need to do here is just make sure that it's labeled as a sound. The rest of this stuff is all exactly the same. This stuff is also set to 0. All that stuff can be exactly the same. So again, I do think we could share a lot of this code. It's very, very highly correlated to the previous routine, the bitmap version of this. So it does seem like we probably want to pull some of this out so that it's not, so that, you know, if we do need to modify it, change the way it was being done, that it won't, you know, we don't have to remember to do it in a whole bunch of different places. So I think we're down to mostly the end now, where we just need to say, okay, the chain part of things, when we actually do that, so a couple things. I'm thinking in my head as well that actually we should reuse the grid system here we could have the grid actually correspond to the channels. That kind of sounds somewhat compelling to me. I like that. I think we should probably embrace that. That might require a couple of changes, but I think that might be nice. All right, so going through here, when we actually have to fill out the chain data, we actually do know what that would be. And if this case gets hit, that's when we know we need to chain. So what I propose is we just have a chain value here. We set the chain value right off the bat to be none. And so normally when you output a sound, it'll just get a none chain. But then when we come in here, if we had to clip that down to a max sample count, we know that we'll go more times. And so we'll want to do an advance on that one. That way when we get down here and it's time to store it, we just know what it was that we needed to store. So finally, what I would say is now we can make the while loop happen. We can just say while there were any samples, keep going. And I think we're done. So that's a pretty stable way to output that. That looks pretty good. I'm going to slap a to-do in here because at some point we're going to know what we want our block size for streaming to be because we'll have some idea about how the streaming reads perform. And we'll want to say, look, use this big of a buffer because that's what we're using for backing. There'll be something clearer about this at some point, right? And so that's when we want to take a look at that. Now, when we do the sort of output of the sounds here, remember they are not tagged. So that's the other end of this that we have to make work. And you can see that there is part of it that won't work. In fact, let's actually just go do it because we're going to have to. So the part that won't work is the fact that we split these up into multiple channels and assets. So we kind of need to actually make this be aware of that. So in here where we do our process audio import, for each channel, we need to create a new asset ID. And you can see that happening in here. It's not going to work properly, right? And this asset index needs to, this asset index needs to increment as we go per channel and per chunk. So really, this part here, this is pretty tricky. We need to reserve effectively a block of assets. And so as we go, each time we need to like set to incrementing asset IDs as we go, right? The only tricky part about that is right now we don't actually compute how many asset IDs we're going to need ahead of time. But it's not particularly hard to do. So maybe we should just do that. So let's jump to reserve asset here. And you can see that when we do this, we just have to, we would just need a thing that's like, normally just reserves a single asset. So we would want to say if asset count plus asset count is less than or equal to max asset count, then we're good to go. Otherwise, it's an error. So in here, when we get this and we reserve one of these, what we could do now is say, oh, well, the result's going to be asset count, but then we're going to add an arbitrary number to it. So we basically reserve these in blocks. So then when we get this asset index here, that asset index is actually going to be something a little bit more squinky. So outside of here, we have to do a contiguous asset block acquire, right? And so we have to think about this a little bit harder as a result because that asset index is actually a block of asset indices, and then we go through getting them out one by one.
What I don't really have a good way of doing here is knowing whether I need to rewrite them or not. But I think we could just let the routine below do that. Like it can just look at each individual asset and see what part of it needs to rewrite. Like whether it needs to get new data or whether it can just rewrite to the same location because it's not going to change size or something.
Seems okay. So in here where we do asset index file, when we grab out just the 001, really we just need to know inside this piece of information how many of these in a run we're going to do. And we know that here, the thing that's going to be tricky is in the stamping. So, metadata, there it is. So in the stamping, when we go through each of these things to do the tag, the problem that we have is this that array of tags there that we're storing in that asset source file as a piece of information. We don't really have a way to do that for sounds because they could have arbitrarily long asset chains associated with them. And so I'm not sure how to harmonize these two paths because we basically want to call the same thing. And it almost works. So for any sound that wasn't streaming, it would work. And we could even use the file asset indices to just record the channels. So that almost works, but we just don't have a run count for them. And I guess what we would need to do is add that in here. But yeah. Oh. Wait. I'm overcomplicating this, aren't I? We don't need to apply any tags at all to the asset chunks that are just streaming chunks. Because only the first chunk gets pulled based on tag. And then it just advances to the next chunk. So actually, we're fine. Yeah, that's actually not a problem at all. I take it back entirely. So really all we need to do is do this per channel. So inside here where we go, while sample count remaining, right before that part, this is where we would reserve the number of assets that we think we need for the sample count that we have, right? And so we would just say like total chunk count, and we would say however many sound samples there are, whatever that max sample count is, let's do a roundup, right? So however many chunks we're going to have is this many, right? Because we're going to, when we do that divide, we know that we're going to have a rounded up number of chunks, right? Get that total chunk count, reserve that many assets, right? And so in here, when we get out which asset index we're using, I don't have a way of knowing whether this audio can be used again the way that it was, because unless we actually stored something in there that said how many it was, we actually can't figure that out, I don't think, right? Because just knowing the base index, we would have to go read the chain length ahead of time. Which I guess we could just do. Yeah, I actually... suppose we could just do that. Just check the chain length. Actually, yeah, okay. So what we would do is do this. We'd just say, look, if we don't get an asset index, then we've got to go like that. And we've got to get, you know, out of the asset store a chunk that's as many, you know, we've got to get a block of allocated asset indices contiguous that are as many as we need. We can look and see if from this asset index, would it have reserved as many as we wanted it to, right? We can't actually do that because all we would have to do is look through each individual one and see whether or not it actually can be chained, right? So in here, when we get a sound asset, right? In here, if we just got each asset as we go and verify that each one is set to chaining, I think that's all we need, right? We don't really need to do anything else, and then we can just save the exact, we can just use the exact set of asset IDs that we want. So in here we would just say for, you know, chunk index equals 0, chunk index is less than blah, plus plus chunk index, right? And we would say, look, we want to go up through, we don't need to check the last chunk because we don't care what that's set to. But for all of the other chunks, we just need to get them out of the file, which is this, right? And we need to make sure that they're actually set to streaming. So we need to make sure that, like, this thing is set to load its next chunk. So if we look at one of these assets, which is hha.sound.chain, if it's equal, we're fine. If it's not equal to what we want, then we're done, and, you know, all bets are off. Right? So basically what we're doing is we're saying, okay, we know we need this many contiguous asset indices, right? Because we're going to have to store this sound as a block of that many assets when we broke it up. So what we want to do is look at the current chain that we recorded. Is it that long? If it's more than that long, great. If it's less than that long, then we need to allocate a new block, right? So just chase the chain and see if it goes that long. Problem solved. So looking in here, if I go out to file formats and I put loop in there and we go, that will give us whether or not we need to allocate a new asset index. If we do need to allocate a new asset index, off we go. And we can store which one, you know, we can do reuse asset equals false or true or whatever, I don't know. And then we can just do it here. So then when we come down in here, we can just do, if we're supposed to reuse the asset block here, then get it out. Otherwise, don't bother. And we would just need a way of making sure the asset index gets updated appropriately, which is pretty simple to do. So in here, we would just do this. That gets out the one from that chain. And so if we're going to reuse it, we reuse it. If not, we just start with nothing, and off we go. The asset index at the end of this has to be incremented because every time we're going to use a different slot, and then we're done. So really the only thing we're left with now is that this part here needs to take the channel index, and that's fine. What that means is we do have a maximum channel count. It's 64 channels. I could even do it this way. Right? What's that? Where's that? Where's that at? Show me where that is at. So what I could do even is address it like that, right? So we can actually use asset import grid max times asset grid port id max grid max worth of channels. We do still need to do a check to make sure that we don't have too many of those, because that is still a thing that could happen, right? So in here, like, we do have one other asset memory problem. This error is not in the right place either. It should be probably here if we didn't get one. Right? So if asset index isn't true, we just do the out here and say we ran out of memory. So I think that's all good. I don't see anything else particularly problematic about that. Everything seems good there. Yeah. So the only thing we don't have is we currently don't have a way of... oh, and also the error can happen here too, right? So we need to clamp that, and we know the max channel count is just however much we could have stored in here. So asset import grid max squared, that's however many things we can fit and still flush through the pipeline. You could argue that we should maybe we should have done this a different way. That could be true. I don't really know. But, you know, just keeping the pipeline simpler, we might as well not do anything too fancy. Then the import grid tags side of things. That import grid tags can now have the channel tag included on here. So back where we were actually going to stamp this guy, so, you know, in the import path, right, where we come through here, oops, sorry, that's the parser. When we do update asset metadata, you know what I mean? That's got the grid tags sort of baked into it. So you can see we've got the append tags here on the import tag array. That's what we parse out. And then we have the grid tags here, and that's what comes from like the type of file. So this grid tag just needs to be set to what we normally want to create for sounds, which is channel IDs for everything. And so that's pretty easy for us to do. We just need to save a version of this that's like our global audio version of that, right? And so that's what we would need to do next time to get those channel things correct. So effectively, like in this HT context here, like this part, right? What we would want to do is have a thing that's like, these are the import grid tags that we use, like this. Like that, right? And so in here, where we come through and say, oh, it's a sound or music, we would just say, oh, good. Just use the audio channel tags, and that'll stamp everything with the correct tags for a channel as we go, right? And that would be it. So everything else would just work. And the metadata update would just correctly stamp everything, which is awesome. And I think that's what we want, right? That's source file. That's an audio ID, by the way. So, sorry, sound ID. Why did I call it a sound ID? I don't know. Just looping through here. Sample count, that's true. Just make sure all that gets lined up properly. That's all good. I think that's it. I don't think there's anything else we got to do there. So I'm going to call that a day. And so we've got, I think, we actually have almost all the call in there. I do need to actually create those channel. So I need to do this. I need to make that grid with the stamped ones. But that's it. And so what I would like to do is go ahead and save that for next weekend. Everything seems to be in place. So it's really just a question of let's go through and actually get out the fine-tooth comb, debug it, get it working properly. But then I think we're importing sounds properly. And music. And streaming music. So everything's in place. And so next weekend we should be able to actually go through there and get it working. Let's go ahead and go to Q&A. If there's any questions about what we were doing there, let's get those going. Not related, but do you have any thoughts on Pony Lang? Nope. I've never used it. No questions? That's good. Flightless Hippo, how are you feeling about the way the asset system is working out so far? It's pretty good. I think I don't know about the grid-based import idea, really. It's basically like a sprite sheet import thing. I think it makes it easier for the artists, but I don't know. So I'm not sure if that, because we could have just had you save out individual PNGs or something, right? So I'm not sure. I don't know if that was the right decision or not. I like the way it's shaping up so far. Basically, there's a few things about how the import goes that we definitely could do better. If I was working 8 hours a day on this, there's a bunch of things I'd clean up, but you can only do what you can do. But it's pretty good. What does good documentation look like? I think I've heard about you and John talk about documentation being really bad and soul-sucking when it's auto-generated. So what does good human documentation look like for programmers and for users? I guess what I'd say is I do like auto-generated documentation for one aspect of things, which is I like everything to be hyperlinked, and that's something that an auto-generator can do well. So I do like that part. MSDN actually used to do this pretty well. It kind of got a lot worse. But if you look at something like, create file ex or something, right? Create file a, it's fine. So it used to be, I think, and maybe I'm making this up, but these were hyperlinked. So you could click on handle and get to the definition of handle, right? When you come down in here, sometimes that happens. So, it's like, oh, I go down to security attributes and it's hyperlinked, so I can go to that, and that's good. But I prefer all of those to really be hyperlinked as well, right? And I like that aspect of auto-generated, right? And C alsos and those sorts of things. I like having a really dense interconnectivity so I can just click around. What I don't love about auto-generated is that when I need documentation, and this is not necessarily a popular opinion, so I'm talking about my preference. I actually don't like this kind of documentation. People seem to like it, I don't. I don't need you to tell me that LPC stir LP file name is the file name, right? A lot of times I see this documentation and it's like D word desired access, the desired access, right? And it's like, I don't need you to tell me that. What I need you to tell me is all the stuff I can't tell by looking at this prototype, right? So what I want to know is stuff like, okay, you know, when do I need to fill out each template file and how are they related to this other thing? So per parameter docs, I actually don't like. What I like is per concept docs. So, you know, give me a section called template file and say, the creation disposition flag and the template file parameter work together in this way. If it's set to 1, then the template file has to be pointing to this kind of template, you know, that sort of stuff. And go through each of the things that I need to understand to use this effectively. That's what I like. Furthermore, I like that as a broader thing for individual docs for a function as well. So create file should have close handle discussed in it. Like, I'd like to see that. Create file, close handle, or create file, read, write, close, right? So that I can see like, oh, okay, so this is supposed to be like a set of things that go together. I like seeing that. Like, okay, I open one of these, I close it, in between I can read and write or whatever, right? So bringing me into the sort of the stuff that you know because you made the API, but I don't know because I've never seen it before, giving me like what those bundles are and how they work together, that helps a lot too, right? So keeping those things in mind, I think, are pretty good, right? I'm going to take this in reverse order. So like Unix man pages, because they lean closer to conceptual documentation, would be more preferable. Yeah, actually. I like it broken down by concept, not by element, because the elements often work together. If one of these parameters is truly standalone, so maybe DW share mode doesn't depend on anything, then great, document that by itself, because that's what it is. But assuming you've got pieces that work together, I want you to discuss them together. Does the C code run faster in general if you place something like width divided by 2 and height divided by 2 by the left binary shift? No. The compiler knows those pretty well. So usually you won't. Usually the code that's generated by those two would be the same. Sometimes not, but most of the time, yes. Let's see. About MeowHash, do you have any resources on how you came up with it or where I could learn more about designing such? I guess what I would say is if you want to design your own hash function, there's a lot of things that you want to learn. And I would say, first of all, you'd have to have a good reason for why you wanted to do it. Like why do you want to design your own hash function might be the first start. If it's just for curiosity's sake, that's great. Otherwise, I would say don't make a new hash function unless you have a goal. With MeowHash, it was to try and be fast, right? Because there really aren't any fast hash functions out there that are any good. And that's still kind of the case. MeowHash isn't as good as I'd like. We're trying to make a better one that still runs at full speed. We haven't quite gotten there yet. We thought we sort of had, but we hadn't quite yet, so we're still working on that. So we're hoping that the final version of MeowHash will be higher quality than the current MeowHash is, while still running at basically the same speed. That's what we're working on now. But again, like, it's a pretty complex topic. You probably want to work with a cryptographer on it if you're really trying to do something serious, because you need a lot of domain expertise. That's what I'd say. Do modern game engines have their own sound synthesizer, or do they just import sounds from other software libraries? I would say it's a mix. Typically what happens is you have a bunch of audio editing software that your sound designers are using to produce all sorts of stuff. But then in the game engine, you typically do have something that's more advanced than Handmade Hero. So at the very least, you typically have a lot of sound effect sort of stuff, like adding reverb dynamically, depending on like where the player is in the world, you know, having sort of different things. Oh, a grenade went off near the player, so now the sound is like their ears are a little shocked and things are happening there, and so it alters the sound as it comes out of that. Or, oh, we're slowing down time, and so that's an effect, right? So typically you at least have all those effects. Whether or not a modern game engine employs stuff like FM synth, that really depends more on the game and whether it makes any sense for them to be doing things like that. But it can certainly happen. Really, again, it just depends on what you're doing. If you're using an audio library nowadays, those audio libraries like Rad ships the Mouse sound system, and like there's all kinds of stuff in there, right? Like, I mean, it's just who even knows? I'm not up to date on like what a lot of stuff is, but there's tons of crap like mixing modifications and how sounds go together and all this sort of stuff. And then there's like Fmod's another popular one. And again, like I mean, I just don't even know like all this garbage, right? I mean, there's a modulator for who knows, right? I haven't looked at any of this stuff, but basically, yeah, you've got just tons of crap going into the sound system. How much of it's actually necessary or makes any difference whatsoever is, I think, probably up for debate. But what most of it is designed around is sound designers come from a specific world and they think in a specific way. A lot of what those tools are designed to do is to make it as easy as possible for them to utilize their vocabulary of how to make sound good without them having to learn like a whole bunch of other things, right? So a lot of what those tools try to enable is let's give the sound designer an interface similar to what they're used to in a sound package for what happens in the runtime game, so when they tweak stuff, they can tweak stuff correctly, like and intuitively, right? Could you demonstrate in one episode how you implemented CMirror version control? It seems very interesting. I mean, yeah, maybe we can go into that at some point. The short answer is the version of CMirror that I use now, which is a complete rewrite. It has nothing to do with the one that was publicly released. It's based on the concept that you just, in addition to storing the versions of files, you also store all of the metadata in a separate database. And every machine keeps that. And then two machines talk to each other. They just ask each other what they've got and update it that way, right? So it's really a mirroring system that happens to also understand versioning. And it just works way better than anything that I've used before. Because instead of all this nonsense about branching and merging and all this crap, it's just like, look, I don't care about any of that stuff. I realize there's reasons for it, but I don't want any of that. I just want all my machines to stay in sync. And if I create multiple versions of a file because I edit it in two places, just give me both versions of the freaking file. And I'll deal with it later, right? And so that's what it's designed to do, is to keep all your machines in sync. And if you've done different things on different machines, instead of making that be this big emergency that breaks everything, it just puts them all in place and says, look, do whatever you want. Here's several versions of this file because everyone changed it. I'm going to leave yours, and you just merge in these changes when you get around to it, right? And it's much more pleasant that way. For situations like what I do where there's very few programmers or artists or whatever, have very, very few people doing things, it just makes things so much easier than the like, let's grind the entire team to a screeching halt because some source code control conflict happened. Which is like the Git way of living with Git. Everyone's like running stash all the time, trying to like get, it's just dumb. Um, so how many times have people given you the old "why reinvent the wheel" line? I've never seen a discussion about building code from scratch, not have at least someone smugly break that one out. Um, yeah, like I guess what I would say about that is that it's I don't even really understand why people use that phrase. Like we don't have any wheels anyway. Like I mean, the concept that we have something as good as a wheel right now in programming is ludicrous. We don't. I think I've said this before. A wheel is a perfect machine. Um, the reason you say why reinvent the wheel is because it does exactly what you want it to do. There is literally nothing like that in computing. There is no game engine you can get that's even close to good, let alone perfect. And so it's always you're making trade-offs, right? You're saying, well, I want to save time, so if I use this, it's similar to saying like, we have square wheels is what we have in our world right now, and if you don't want to go through the trouble of forging your own wheel that might be better, you can use these like square-shaped wheels, and your car will like go like this, but at least you didn't have to build the wheel yourself, right? So that's what we're at. So anyone who says why reinvent the wheel, I think fundamentally doesn't understand what a wheel is. Um, might be the way to say it. Uh, is A and B. Even if you do understand what a wheel is, and you thought that our current wheels were similar, like our current stuff we have in computing is similar to actual wheels, which I think is a ridiculous notion that if you actually think that, I don't understand. You probably don't really understand computing very much, I guess is what I'd say, because we're just not even close. But let's say you thought that. Even in the real world, how many vendors of tires are there in the world? And how many types of tires are there? I mean, there are thousands of different types of tires in the world right now. And that's just the wheels that go on a car. There's the number of different wheels made by people in the world is stunning. Like, there's all kinds of wheels inside mechanisms. Those are all made by different people, and they're different sizes, and they work different ways, made out of different materials with different heat profiles, different surface textures. There's wheels that are used for grinding. There's wheels that are used for driving. There's wheels that are used in gearing. There's wheels that are used as disc brakes. I mean, saying why reinvent the wheel is just dumb. It's sort of like saying I'm too stupid to believe that humans can make progress or something, right? Like I just believe we're done. It just doesn't make sense. Even people who make wheels make new wheels right now, and that's the wheel. It's been around for thousands of years, right? I got nothing. Like I just don't know what to say to people like that. It's like their brain just can't even conceive of something better than what they have. Uh, it's like a child playing in a sandbox. They just don't. It's like it's a very immature statement, I guess is what I would say. Speaking about MSDN, I had an issue where an old version of docs had a remark that was important for a certain call that some value should be set a certain way in a struct. Not there on the new version. Oh, great. Yeah, that does happen. Ack. Anyway, doesn't the remark section usually have information on things like close file for the create files call and so on? Yes, and I like MSDN on the whole. I think it's pretty good documentation. Like if you've ever used like Apple's documentation, for example, it's a pretty clear step down. And so I think MSDN, if you can manage to produce documentation that's as good as MSDN, you're actually in good shape. That's a pretty high bar, actually, for documentation. A lot of documentation isn't as good as MSDN. So I wasn't trying to slag MSDN at all there. MSDN's pretty good. I think it got worse. Like it used to be better. The CD version, you used to be able to put in your machine. It was a lot better. It had a faster index you could use to jump to things quickly. It had more hot linking that worked better. So it's degraded over time as they've done the web nonsense to it, and they probably ended up with people who don't really know what they're doing, making that website. So it got worse than it was, but it's still pretty good. In the pantheon of documentation quality, it's pretty high up there. And if you produce documentation that's as good as MSDN, that's good enough, right? Could you do better? Sure, but you're already doing pretty good if you've got to that level, right? A lot of docs just fundamentally aren't as good. Why is functional programming not dominating corporate programming? I guess I don't really understand the question. Functional programming, like any style of programming, is useful for some things and not useful for others. And I would say, generally speaking, most people do functional programming. If they're good programmers, they do functional programming in places where it's possible. But in a lot of cases, it's just not feasible to do functional programming for the things you want to do. And so, functional programming tends to live down in the leaf layers of things, business apps or otherwise. All right, I think we're done here. Oh, I changed debugger to remedy. If you go to remedy.bg.itch.io, it's in there. I should probably change. I don't know if we. Let me look. I don't actually know if we can. Can we do something here where let me see. So if I go to. Oh boy, this is good. I don't know how to do this, but I'm gonna try. So if we go to channel on Twitch, if I edit. Let me see, edit panels. So if I say, I'm going to go ahead and try to add in here links at the bottom of the Twitch window. So if you're watching the stream live, you can get those. So let me link to those here, or try to, and you can tell me if this works. So I'll put that one there, and for coder, I'll put here, and we'll see if this will update. So let me see. All right, so if you refresh your Twitch window, if you're watching this on Twitch, underneath there's like a thing that says like about Handmade Hero, and there's a thing that says how to support the project. I added a line that says you can also buy the tools used on stream. The editor is for coder and the debugger is remedy. If you click on those for coder or the remedy link, they should now take you to the itch.io page for each of those products. So if you want to buy the editor or buy the debugger that we use on stream at some point, you should be able to find them there. That's, I guess, that's the way I would say is easiest to get to those things, because I'm there. Yeah, those links should probably just be generally available. Someone could probably bake those into Insobot as well, who knows how to use Insobot, so that when people ask on stream, you could answer. No, 4Coder and Remedy are commercial. You have to pay for them. They're very cheap. They're much cheaper than they probably should be. I think they're like $9 and $12. So, like, yeah, that's about as cheap as any piece of software should be, in my opinion. Do you know why functional programming languages tend to be closely tied to formal verification and more theoretic work by any chance? Yeah, it's because thinking that you want purely functional stuff is usually the domain of programmers who want to be thinking very analytically and formally about things. They just go hand in hand to the mentality. People who want to do more like, I'm programming a computer, computers aren't functional. They're procedural, right? So, you know, that's the kind of thing that you want to that's the kind of thing that you that's the kind of thing that's just the people who would bother making a pure functional language or are close to it they're going to be people who are thinking along those lines, because why else you would never build one otherwise. CPUs aren't functional. You would never go, I want to program a computer with a functional language, if what you cared about is programming the computer, because computers aren't functional. So it's inherently not the right language for programming a computer. But if you want to program a theory, right, if you're trying to make a theoretical verifiable thing, then functional programming is exactly what you want, because it's the only thing you can verify, right? Is something that has 100% deterministic input-output, right? And so, you know, I think those things make perfect sense. People who want to program computers and get the most out of them, they want procedural. People who want to program computers and be able to prove things about what they write, they want functional, because you have to have it. Procedural languages is just incredibly difficult, if not impossible, to do formal verification on them. You know. Is it license-based? No, neither are license-based in the sense that they don't require any kind of DRM. They are license-based in the sense that you have to buy a license per one that you want to use. But once you buy the license, it just installs in your machine. You don't have to run DRM or anything. All right, last question from Brian. Greetings, Casey. How do you find balancing duplicating code versus trying to generalize a function? As an exercise, I took format string from Handmade Hero and wrote a format wide string. In the end, I chose to simply take the format, call UTF-8 from UTF-16, call format string on a temp buffer, and then UTF-16 from UTF-8. But now I sacrifice performance for maintenance. Other than if it becomes a bottleneck when profiling, what other things do you look for choosing to duplicate code and making it more a pain to maintain than the benefits of having specific versions? I would say you kind of stated it exactly the right way. Maintenance costs are real. Debugging costs are real. They cannot be ignored because you only have a limited amount of development time. So usually what you want to do, if you can, just do something like UTF-8 to 16 and then 16 to UTF-8 or whatever. Just do that first and then see whether that becomes a hotspot, just like you said. When you're profiling your app, if you start to see those things show up, then it's the time to start looking into it. If that never shows up on a profile, then it's not worth it, right? So you do want to be aware, you want to remain aware of what's costing your time. But if you just don't see things like that showing up, then it's just not the right time to be focusing your efforts there. Because again, just like you said, I think you stated very well, if you make things more performant, you typically make them less maintainable, and that's a real cost. And so you don't want to pay the cost if you're not getting the benefit. And having increased performance for a particular routine only matters if that routine actually is showing up as costing you something, right? Okay, let's wrap it up. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can follow along and do your own experiments with it. I also want to remind everyone, Handmade Seattle, as I talked about at the beginning of the stream, Abner is running a conference. For those of you who don't know him, he's the fellow who organized everyone to do Handmade Network, the place where a lot of these products are hosted. And that's going to be in Seattle on November 16th. So mark your calendars. And if you are interested in that, head over to handmadeseattle.com, put your email into this notification box here and hit notify. That'll, oops, that's great. That'll basically put you on the mailing list so that when the conference schedule and when to buy tickets and details and all that stuff come out, you will get notified with that information. So you can, yeah, plan a trip. Anyway, that's it for today. I will be back next weekend to go ahead and get that sound import stuff debugged. I'm assuming all we did was type it in. I'm assuming we got some bugs in there, so we want to go through and actually put all this stuff together and make sure that all of it works. That's about it. Until then, have fun programming. I'll see everyone on the internet. Take it easy, everybody.